Yo, what's up? We're gonna um so I was doing this on YouTube last week, and I want to continue here. Basically what we're doing is ex- exploring space really. So yeah, we got the Celestia software, which is pretty cool. And yeah, last week we were looking at Jupiter and just like learning the main things in the software. And today I want to explore the solar system for sure. But I realized that there are a bunch of things that I could do to kind of configure the Celestia software to be better. Mainly by adding some things to it. So so yeah, basically Celestia, that's a space simulator, really. And you can explore you can explore um, you can explore oh, I think this is it. Sorry, I'm a little bit all over the place. You can explore the solar system, planets, and beyond. All right. So um, it's free to download and it's not very big. But the thing is that that's just that's just that's just like the base, and then I guess because it becomes so large, probably you can add more things into it. So people have made these extra community packages, which we can see here, that contains a lot of textures and new planets. So let's see what we got on the list here. Let me actually start the download, maybe. Um, let me like start the download. Okay. Before before we look into that, okay. So I got the torrent file, and as we can see, it's like 10 gigabytes. So my internet's pretty good, but I don't know like I don't know like how good the seeders are gonna be. So yeah, it's actually pretty good. Oh, somebody else is doing deluge. Bigly BT. I don't know what that is. QBittorrent. MicroTorrent, we all know from our Windows days. All right, this is gonna take a while, even though we got the good down speed. So let's just give that a few minutes. And all right, and let's just look at the installation instructions here. All right, there's the basis of Celestia Origin collection prepared for various operating systems. Yeah, the collection should be installed to any folder of the user's choice regardless of where the Celestia program is installed. In addition, the user can make an unlimited number of installations with different settings. Okay. Blah, blah, blah. In case of Windows and Linux, a portable version of Celestia Simulator will be installed with the collection. Okay. In the case of Mac OS, the simulator must be installed by the user separately, and then the collection data must be connected in its settings. All right. All right. Oh, it's speeding up. I guess we could like prioritize here. Just to finish this one first. Completely extract the contents of the archive to a separate folder. Okay. And then run the installation script. Okay. Specify the full path to the folder where the collection must be installed. Select the compatibility mode version of Celestia. All right, I got the 1.7. Select the desired set of textures. The proposed options are suitable for very weak PCs and most laptops and include the installation of level 2. Okay. Okay. And then it's all good. All right. All right, so that's the core. That's the core. Which has just like the basis resolution. And then the extra textures. Then there's another one which is called the extra textures archive, which is a high quality textures for the Celestia Origin, which I guess is just this collection. And it has a higher resolution up to 64K. And then, so I'm just wondering, do we install this in addition? I have a pretty old computer, but it's running very optimized, so I would be very excited to see how well it's going to do with the large models. It has like an okay GPU. It's not great, but I think it's got like 4 gigs of RAM or maybe 2, which is, you know, it's not exactly 24 gigs, which you can get these days, but It's okay. And then finally we got the extra trajectories archive. Okay, well, you know what? That's great. It's actually almost finished. It's actually almost finished. So I kind of want to just look in the archive a little bit, but I think today we're gonna be fine just with we're just gonna use the we're just gonna use the whatever's in there, because I'm so like there's just so many things that I don't know about the solar system as it is. So so yeah, let's just play around with let's just play around with the basics and just get to know the basic things. All right, so let's begin. We got the Earth. Wow, that is a nice Earth, you might say. And this is real time, so I'm here. I'm up here. Norwegia. The way north. So as you can see when you zoom in, it's just very low resolution. So I'm guessing that as that kind of increase when we install the other textures, that's going to be like better, you know? That's going to be better. All right, we got the Earth. And and then that's not really space, you could say. And I would be inclined to agree. But we have in space, we have a few things here. Wow, this is cool. So you can see, whoops. Obviously we got, you know, all the countries and everything. Cities, they are in green. And then I see two other labels here that are in a different color. One of them says Hubble, the other one says ISS. And I think so. I guess Hubble, that's a space telescope, and then the ISS, that's the International Space Station. Wow. Oh man. Can we like? Wow. Can we like follow it? Oh yes. Oh wow. But it's so dark. You see that? How cool is that, huh? So I guess it's like, it's pretty dark. It needs to be in the sun for us to see it. Oh, so that's the orbit. Does that mean, no, it's not on the equator. I wonder why it has this orbit. It might be somewhat random. But you know what we could do? If we just go back a little bit in time. Let's see, reverse time. Whoops. And then we just send it. We'll just send it back. And I'm certain it's gonna illuminate. Yeah, it's getting some sun on it already. So then we can go back to real time. Look at that. Look at that. So somebody spent their time like creating this. Wow. I can't believe people are like in there, you know? Just like hanging out. So that's the ESA module. That's a NASDA. Not sure what that is. Here's the docking station, I suppose, or like docking. They dock with see if we can get a little bit more light on it. They dock with you know, like spaceships that come up with cargo and other things. It has some pretty neat solar panels. Are they bidirectional? It does seem like it. Are these also solar panels? Wow, how great is that to assemble this thing in space, you know? How'd they get these out? How'd they get this out there? I can't even... When I go camping in the woods, I'm like, how do I get all this stuff there, you know? Okay, and then now we gotta real time it. Oh, so it's over, now it's over South Africa. You can see. Wow, this is cool, huh? The International Space Station. So when the astronauts arrive, you know, they will arrive through here. I'm just guessing, but it does seem kind of intuitive. They're gonna arrive in through here. They're gonna attach their vehicle, and then they'll be welcomed here, and then they'll check in. They probably got like sleeping pods. Are these like the sleeping pods are like up there? It's too bad they're gonna decommission this, huh? But I guess it's getting a little bit raggedy. Raggedy. Yeah. Wow, imagine the view from up there, huh? Do they even have windows? I guess windows are kind of expensive, right? So they probably got a special window unit somewhere. All right, well, that's cool. Let's go back to Earth. Select, center, and follow. Cool. Can we do Hubble? I just want to have a quick look at Hubble. Let's see the model. Let's see, go to object. Hmm. Oh God. Yeah, I got it. Okay, there it is. So this is also illuminated. This is just is this just the Hubble Space Telescope? Right? Wow, I didn't know it was in orbit around the Earth, but I guess it is. Yeah, this is an old familiar face. Huh. Wow. You know, NASA gets a lot of shit for being inefficient compared to SpaceX, but at least there are some things there. At least this is up there, right? So it's got this signal receiver and then solar panels. And then I guess this is the light. This is the you know, telescope. The long distance viewer. And it's just like, what's over there? What's over there? I mean, you can see that it's made in a vector program. I guess all 3D models are made in vector programs. I don't know, is there anything over there? Chariclo? Psyche. Oh, it's looking right at Psyche. Okay, that's interesting. Okay, so. Alright, cool. We're making progress. Oh my god. We got the moon. Let's go to the moon. Hmm. What are all these things? Are they like countries or something? Sinus asperitatis? Let's Google that. It's an area of lunar mare that extends southward from the Mare Tranquillitatis until it joins the Mare Nectaris to the southeast. Crazy. They got it all mapped out. They got it all mapped out, don't they? Out there on the moon. Lunar Mare. The Lunar Maria are the large dark plains of the Earth's moon, formed by lava. Oh, I see. Right, so that's just like these things, I guess. And then we have other parts of the surface. Yeah, so you know, it has these like dark spots, and they're like basalt. Then we got all these other things. Schwarzschild. That's German. D'Alembert, that's French. Campbell, that's English. Roshtevensky, that's Russian. Got anything non-European? Got some Latin stuff here. Greek. Mandelstam, is that, what's that? Is that Hebrew? Hmm. Okay. Mir. That's the Russian. Where's that? Is it even there? Is it still there? Go to, that's... No. I don't know if it's there. Oh God. Okay, okay. Let's go back to the Earth. Let's go to the Earth. Center and follow. And let's go to real time. Let's go to current time. Like so. And now I want to go and I want to look at the, I want to actually look at the planetary, I want to look at the planetary, wait, where are we going? I want to go to the planetary orbit. Select, oh, select, center, go to, and follow. All right. All right. All right. So we got the sun in the center. You know, this is the sun. Beautiful. It has maybe some sunspots on it. Yes, indeed. Then we got the orbits. These are like meteors pretty close to oh no. Pretty close to the Earth. Man, it's crazy how slowly everything kind of moves in space. All right, so that's the solar system. So tiny. And then we got the other solar systems. So there's a lot of interesting stuff in our solar system. There's like the moons of, I think, of Jupiter that are pretty interesting. Obviously Mars is pretty interesting. We might look at that in a different episode. But today I want to travel to a different solar system. So we got Sol, Better Call Saul. We got Proxima here, Proxima Centauri. Does it have any information? No? Be pretty great if it had some. If it could like tell us anything about it, you know? All right, but you know what? Let's just go to Proxima. It's about 4 light years away. There are planetary companions present. Is it only But I think the thing about Proxima Centauri is that it's actually not just one star. It's whoops, this is in Norwegian. I want the English one. I thought it was multiple stars like circling each other. Yeah, Proxima Centauri is a member of the Alpha Centauri star system, being identified as component Alpha Centauri C. Oh, I see. So you got right, and it's 2.18 degrees to the southwest of the Alpha Centauri AB pair. Right. So it's actually like it's one star, but it's kind of right next to 2 other ones. So let's go there. Right, it's over there. We're following it, and then oh, it's got planets. Let's go. We're traveling. Haha, sick. And it's got 2 planets. Wow. Look how fast you can travel. Just 4 light years if you just really go for it. Rigel, Kentaurus, Ptolemy. Are these the 2 other guys? I guess these are probably. All right, so that's that. Proxima, it has 2 planets. Are they any good? All right, here we go. Proxima Centauri B is an exoplanet within the habitable zone of the red dwarf star Proxima. Has it got anything good? All right, let's look at the composition. It's might not be tidally locked. Little is known about Proxima Centauri b as of 2021, mainly its distance from the star and its orbital period. But a number of simulations of its physical properties have been done. Oh, that'd be cool. It'd be cool to see like what's in it, you know. Or maybe not. Maybe it's not important because it's but it does say that it's in the habitable zone, didn't it? A number of simulations of its physical properties have been done. A number of simulations and models have been created that assume Earth-like compositions and include predictions of the galactic environment, internal heat generation from radioactive decay, and magnetic induction heating, planetary rotations, the effects of stellar radiation, the amount of volatile species. The planet consists of the, the, the amount of volatile species the planet consists of, and the changes of these parameters over time. Alright, so basically they don't really know. But they tried. It has less water. All right. Okay, so it says it's pretty cold. It's like minus 40. So they don't know, but if there's an atmosphere, it's probably going to contain oxygen-bearing gases such as oxygen and carbon dioxide. Together with the star's magnetic activity, they would give rise to auroras that could be observed from Earth. All right. All right. All right. We'll look more. We'll look more into it later. So that's here. What about the Rigel Centaurus? Is that? Yeah. So that's the other ones in the that's like the right. So these guys are kind of like, where'd they go? Oh God, these guys. Right. Right. So we got this guy here. Right, and over there is the other part. So they're kind of interacting, I think. But this guy's alone. It's a star. It's just huge, right? Is this Earth? Oh, so what's that? Oh God, it's so far away, but it's huge, probably. Wow, it's so easy to get lost in space here. This is that. No. Oh my God, what's that? Red? Something red? Beetlejuice. What? What's Beetlejuice? Gotta look that up, obviously. It's a red supergiant. And then this, what's that? Sirius. All right, we're pretty close to Proxima. And then what's this again? Rigel. Right, so we can see it right up there. Rigel, alpha. That's like alpha. Alpha in the Alpha Centauri solar system. So you know we're gonna go. We're gonna go there. And I'm wondering if this solar system doesn't have any planets, probably because it's probably really violent. No. See, this one has planets. Yeah, these two, they don't have any planets. Right? Oh god, where did it go? So is it orbiting? Is it like orbiting the other one? Yeah. Fascinating. This is real time. This is like right now. Is anybody else looking at this? We gotta look into this. Solar System Berry Center. Is that? Yeah. So that's us. That's probably no. So that's us. Here we got these two guys, Alpha Centauri. And then I'm wondering, what's Betelgeuse? These are just like some huge stars. It's not moving. Okay, and then what about Proxima? Where's that? What? Is that it? Can't even see it. Wow, you can hardly see it. But these, so I'm guessing it's very small compared to the. I'm guessing it's like really quite small compared to the other guys. Okay. Yeah, it's just, I mean, it's just so much brighter. It might be because there are two, but it just looks a lot brighter. So I'm guessing Proxima, that's a red giant, a red dwarf, right? It's a red dwarf. Yeah. And then, so that's a red dwarf. Okay, so we got, and these two other ones, they're like the sun, so they're sun-like stars. Yeah, and you can barely see the other small one. Oh, that's cool. So yeah, I said this in the previous episode, but mm, if you read the three body problem, so it's like a pretty popular science fiction book. Then these are the stars they're talking about. All right, let's go back to the sun. All right. Here we are. We got alpha there, I'm guessing. No, it's over there. Oh. Wait, so we can do this. Center. And then we can do follow. No. Right, so we're in the same. It's kind of confusing the way this works. You know, it'd be cool if you could just be like, you know, there it is, right? Okay. What about Barnard's star? What is that? Or should we look at the deep sky objects? Oh God. Imagine like starting out on this project, like Galileo or whatever, like looking up at the star and be like, okay, let's start, you know, let's start categorizing. Barnard's star. I want one with more, with like planets. What's the other close one? What's the next closest one that has planets? C as Leo. C and Leo. Let's go there. So it's a red dwarf, I suppose. C and Leo. Wolf 359. Yeah. It's like really small. My God, look at all this information. And the planet is just gonna be pretty useless. Probably, right? It has an unconfirmed companion. Man, we just don't know anything about space, huh? Like this is like the eighth closest star, and we're like, yeah, we don't know. Might have a planet. It's crazy. Okay, what about this one? Okay, it's got a couple. This is also a red dwarf. Gliesa 411. Lalande. Didn't it say Lolland before? Oh my god, why does it give me the Norwegian one? Given I am in the country, but it's just so useless, you know, look at the information. In the south of Ursa Major. Great Bear. It's a constellation. So it's a red dwarf, but it's the brightest one, and that's kind of what I felt. It felt like it was a little bit larger. Lolland, maybe the planet, that's what I saw. Lolland, so it's got 2 planets. One really close one and one really far one. All right, Sirius. These are cool. These are important. No planets there. Oh man, Ag. Oh, it has the Norwegian A. Okay, let's go here. Ran, like the Kurosawa movie. So this is a soul-like maybe. Agir. I bet you don't have this. I bet you don't have this this letter on your keyboard. All right, so this is it. Epsilon Eridani, also known as RAN. I just don't want to Google RAN, you know. Well, it's pretty young, just less than 1 billion years old. Higher level magnetic activity. My God, I can't believe the people that are working on this. When they're talking to investors and stuff, they're like, yeah, well, how are we going to make money with this? And they're like, think long term, bro. You got to think long term. Like, I'm like into it, and even I almost can't be bothered, you know? It means celestial meadows in Chinese. All right, so does it say anything about okay, so this is interesting. It's the 3rd closest individual star. That's also visible to the naked eye. Epsilon, it's smaller and less massive than the sun, and has a lower level of elements heavier than helium. Okay, but it's like, I guess it's like kind of similar to the sun. Okay. And the planets, really? Doesn't have rings? Okay, so it's the only planet here. It's the only one. Oh. Man. You know when you ask the question like, where's the aliens? Yeah, but I mean, They're not hiding because there's nowhere there it could be. It's just, it's friggin' nothing, man. Yeah. It's just nothing. Nothing good. Oh my god. Yeah. I mean, we got these suns. We got these suns, these stars, right? But they're Oh. Okay, so these are okay, this is interesting, I guess. So these are the classifications. G2V, that's the sun. So this one is also like the sun. And then we got the M, which is dwarfs. Right? What's this one? K1. TLY. M. So these are dwarfs. A. More dwarfs. So M, that's dwarfs. And then, so what we're really looking for is G. Like, how many G's do we have? Are there a lot? Oh yeah, there's a couple. They're so far. Oh my god. I mean, I'm like, oh, this one's kind of close, but it's almost 20, like 19 light years away. So far. Yeah, and now we're not even on the G's anymore. What are we gonna do, you know? We're stuck in space. Better just go to the pub. Alright, let's just... let's just look at these files. Let's see what's in here. Can we... Oh no. No space available. God. Really? I used up all the space, huh? Well, luckily I have another hard drive. So we're gonna use that. Hmm. What about? Can we go look at where is Psyche? Let's see. So this is an this is like an asteroid or meteor. Um, let's see. It's an asteroid. It's an M-type asteroid, and yeah, they want to go there. Like people want to go there and like and mine it because it has a lot of good rocks and metals. Um, it contains about 1% of the cumulative mass of the whole asteroid belt. So it's an M-type asteroid. Okay. Um, so it's a spectral class, which I guess is like the light characteristics of it. An asteroid is a minor planet. Okay. So an asteroid is a minor planet, an object that is neither a true planet nor an identified comet. A comet is an icy small solar system body that warms and begins to release gases. Right, so a comet is like ice, and an asteroid that's like, you know, it's like made of rock. It's like metal or whatever. All right. Anyways, I have finished moving this, and then I want to extract it. Now let's look at these scripts. So this is where the stuff is inside. It's extracting. And then after that, it's probably the script is going to appear. Oh my god. Oh my god, I went swimming today. Who are these people making this? That's what I want to know. All right, it's about done. 70%. It's getting slower as it's reaching higher percentage. 78, 79. All right, so this is Psyche. I'm wondering if with the upgraded textures we can like we can look at it better. Like it's gonna be cooler. Okay, so I'm just realizing that it's not orbiting the Earth. It's orbiting the sun. And they talk about the asteroid belt, and I suppose you can't see all the asteroids here probably, or maybe you can. But I'm wondering, like, I guess like they call it the asteroid belt. It's like it's like between Jupiter and Mars. Yeah. All right. Okay, so let's see here. We got a script here. This one, and I'm sure it's fine, but I always like to just like read the script before I execute it, you know, so it doesn't like install ransomware to my computer. Okay, what does it do? Okay, yeah, it looks fine. All right, but anyways, that's gonna be it for today. So thank you very much for watching. Hope you enjoyed it, and I'll see you in the next episode.